we're going to have to do two things. First of all, we have to decide whether the original image from lens 1 got inverted or not. And then we're going to have to decide whether this image got inverted when it went through here. So let's start with the image from lens 1. Was the image from lens 1 inverted or upright?
So that would be negative 30 over 15, positive 15.
Because now we're just going back to the original lens.
Yeah. So that gives you negative 2. So that tells us that it is inverted.
I'll call this magnification 1. So that was our original.
So that's saying the negative is inverted. Things that are negative would be inverted. And then if it's, okay. So then,
now we want to do M2.
So it's equal to negative 6.7.
And S2 prime was a positive number, so we just put the negative sign in here. Okay.
And then S is negative 10.
That's very important. That's right. Now, for the first time that you and I have worked together, we have to put in a negative number for the object distance because S2 is also negative.
So that gives you 0.67, positive 0.67.
Positive 0.67 is M2. Okay, good.
So then that would mean that it would be upright, the final image.
Now, let's see. Here's the object. What happened between the object and the first image? Did it stay the same or get flipped?
It was flipped.
It got flipped. And then what happened in the second lens?
It got flipped again.
Did it? What was this?
Because it's positive.
Yeah.
So it stayed inverted.
Yeah, it didn't get flipped one more time. It stayed the way it was before. So maybe I should be keeping track of things here. So here's the image from the first lens. Okay. It would be below the axis, but I'm out of room. So here's the image from the first lens. And now, I'll put it over here. Here's the image from lens 1. Image 1. And now what does, and image 2 is, all right, image 1. All right, and then we have image 2. So is it, so if the object was pointing up originally, the first image would be pointing down. And then how about the second image pointing up or down?
Up.
Stop and think about that. So let's see, the first object was, if that was pointing up, and then it got inverted. So now it's pointing down. Now, this arrow got fed into this lens. So is this arrow going to get flipped again or stay the same?
Stay the same.
Because of the positive number down here. However, this is the object now for the second lens. So it's like we have a downward pointing object. It's like we have a downward pointing object. So how should I draw the final image, up or down now? And this is image 2. Here's image 2, the image from the second lens.
So when it says that is the final image inverted or upright?
They mean compared to the original object. Because that's what we really care about anyway, right? The whole point of this optical device is to give us an image of this object. No one cares about this first intermediate image except as a thought process. No one cares about this intermediate image. What we care about is what we're ultimately going to get from the second lens here. So let's work, so again, maybe it helps to draw these pictures like we did here. If we assume the object was originally pointing up, we know that it's going to, the image got flipped in the first lens. So here's image 1, but then, because that's a negative magnification. But then when we get a positive magnification from the second lens, we know that there's no more flipping. No more flipping, so image 2 is pointing in the same direction as image 1. So if image 1 was pointing down, image 2 is pointing down. And when they say inverted or upright, they mean compared to the original object. All right, and again, you avoided one trap that was important, which is that you remember to put in a negative number here for the object distance. So that's very important for the second lens. So notice how we have to use a lot of subscripts. Here's M1 and here's M2. Okay, so that's part of part B. So we decided that the final image was inverted?
Yes.
Okay. And what about the other part of part B?
It's virtual or real. So the two images again? Or can you just look at
Here,
all
I think we
these
can
on-
just look at S prime, yeah.
So then, in that case, it would be real.
Huh. Yeah, that's right.
It's real because S prime is positive.
Yeah, and that just came out from the math. By the way, one other thing to watch out for, remember that we said earlier that real images always get flipped, in infrared, right? Real images are always inverted. But you can see that doesn't work for negative object distances. After all, the image from this lens is real, but it didn't get flipped. So all that infrared and ultraviolet stuff is only for simple problems without multiple lenses.
Think about that stuff when it comes to
Yeah, when it comes to multiple lenses, throw the chart out the window, throw the infrared and ultraviolet out the window. When it comes to multiple lenses, just do the math. When it comes to multiple lenses, we're just going to do the math. Okay. Everything that we thought used to be true, that we just memorized as a rule of thumb, doesn't have to be true for multiple lenses. Okay. Okay, so we've decided that the final image is real and inverted. So to see if it's inverted, you have to think through the logic of both lenses. But to see whether it's real, you just look at this number over here from the second lens. Okay.
And so C, find the magnification of the final image. So, can we do it from the final image to the object, like that?
Right. Well, basically, all you have to do is, I'll just, so what happened with the first image? Did it get magnified or shrunk?
It got magnified
by a factor of?
2.
Right, it got magnified by a factor of 2. That was this number here. And then what happened with the second image compared to the first image?
It got, it was magnified by...
Let's just, now we're not trying to compare to the object, let's just compare the first image and the second image. What happened to the first image when it was treated as the object and turned into the second image? Did it get magnified or shrunk?
Magnified.
Now that would come from this here, right? That would come from this. Well, actually this is less than 1, right?
Oh, right.
So this, compared to the first image, the second image was shrunk by a factor of?
0.67.
Yeah, so however big this image is, if you multiply it by 0.67, you'll get the sign here. All right, but that's just a thought process. We don't really care who's bigger, this or this. We care who's bigger, this image or this. But if you think through the thought process, we started with an object, and then we got an image that was twice as big.
Right, so that would
And
be
then we got something that is smaller by a factor of 0.67. So the ultimate magnification is just this times this. The ultimate magnification is just the magnification of the first lens times the magnification of the second lens. We just kind of went through the thought process for why that's true. We can also just memorize that as a formula. For multiple lenses, the magnification of the whole system is the product of the magnifications.
I got it.
But it's just really common sense. First we doubled the size, and then we cut it by 2/3.
Right.
So we're really just multiplying by these
2.
in order.
Got it.
So let's find the combined magnification.
Do you include signs?
Yeah, let's go ahead and include the signs.
So it's negative 1.34. So that would mean that would be magnified.
Yeah, what number did you get?
1.34, negative 1.34.
About, yeah, -1 and,
So now that I know
Third.
that the total magnification or combined is negative, can that also be a hint that the final image is inverted?
yeah, very good. We didn't have to do all this work up
Yeah.
here. We could have just found the combined magnification and it would tell us.
Right.
And then we already got this. That would have been the easier way without going through all this. Did this get flipped? That guy get flipped? Yeah, because the magnification really includes the inversion in the signs. So it's taking into account how many times we're flipping. So yeah, that would have been the easier approach. That confirms that we were right in the first place. So what was the magnification? Well, it's negative 1.34. The magnitude of the magnification is positive. So yeah, how do we interpret this? Well, how do we interpret the sign
So that shows us that the final image is inverted
compared to
the original object. And then that, compared to the original object, the image was magnified by a factor of 1.34.
That's right. So if the original object had a height of 5 centimeters, what's the height of the final image? How would you calculate that?
5 times 1.34.
That's right, you just multiply it by that factor. So yeah, actually, the easiest way to find the characteristics of the combined, of the final image is the image distance from the second lens tells you right off the bat whether it's real or virtual. And you can find the combined magnification by finding the individual magnifications, and then that tells you immediately what the overall magnification is and what the sign is. And then you don't have to worry about tracing through from image 1 to image 2, because that's kind of confusing.